We're going to do a composition of transformations, meaning we're going to do multiple in one problem. Okay, so you did need to know those 3 different transformations in order to do this lesson today. So starting off here, the pattern of footprints left in the sand after a person walks along the beach illustrates the composition of 2 different transformations, which are translations and reflections. Okay, so again, translations is a slide and a reflection is a flip. Okay, so your footprints in the sand, that's called a glide reflection. But when a transformation is applied to a figure and then another transformation is applied to its image, the result is a composition of transformations. Okay, so we're doing multiple to one single pre-image to get an image of an image. So our glide reflection with our feet in the sand here is the composition of a translation, followed by a reflection in a line parallel to the translation vector. So off to the left here, if I'm starting at this foot right here, first we can translate it forward along vector W. Okay, so it slides forward, and then it reflects over this line L here to create this image on the top. Okay, so it translated and then reflected over that line L. So the glide reflection shown is a composition of a translation along vector W, okay, followed by a reflection in line L. Okay, so it keeps doing that motion to create this pattern. I know that's not how you walk. You don't translate your foot over and reflect it. It's just a pattern that they're showing how you can make that pattern. Okay, so we're going to do an example of some of these glide reflections. So we're going to take triangle PQR with the following vertices. Okay, we're going to graph that triangle and its image after the indicated glide reflection. So first we're going to translate along this vector. Okay, we know how to do that. And then we're going to reflect that in the x-axis. So just like before, first thing I want to do is plot my pre-image. So that's points P, Q, and R. Okay, so we're plotting those points. Point P is at 1, 1. Point Q is at 2, 5. And R is at 4, 2. Okay, so here's my pre-image. Now I have to do this in the order indicated here. So I want to do this translation first since it was labeled first. Okay, so my translation vector is -2, 0, meaning how am I going to move? We're going to move 2 to which direction? Left. Okay, so we're going to move each of our points 2 units to the left. So point P, 2 units to the left to get P prime. Q, 2 units to the left to get Q prime. And R, 2 units to get R prime. Okay, and just like before, I do want to write out my prime coordinates there. So we have P prime at -1, +1. Q prime at 0, 5. And R prime at 2, 2. Okay? So now what I want to do is do that second transformation. Now when I do the second transformation, you have to go from these prime coordinates. Okay, don't go back to your original pre-image and reflect that one. You want to use the one you just found. Okay, so we're going to reflect in the x-axis. So each of my points are going to be reflected here. So P prime is 1 away from the x-axis. Okay, so we'll count 1 more away from there. And this one we would label as P double prime. So you have 2 apostrophes next to it. Okay, Q is 5 away from the x-axis. So we'll go 5 down to get Q double prime. And R prime is 2 away. So again, 2 further to get R double prime. Okay, so labeling my points here, I have P double prime at -1, -1. Q double prime at 0, -5. And R double prime at 2, -2. Okay, so again, you want to take your pre-image first, do the translation, because that's what was given to us first, find those prime coordinates, and then do your second transformation. In this case, it was a reflection in the x-axis. And you want to use those prime coordinates you just found. Don't go back to your pre-image and reflect that one. Okay, questions on example 1, letter A. Okay, I'm going to have you guys do letter B. Now, in letter B, you're still using these points P, Q, and R as your pre-image. Okay, so graph those points and then find your translation. Okay, find your image after that translation, and then find that image after the reflection. All right, so here's my pre-image, okay, with P, Q, and R. If you're not done doing this problem yet, keep going. You should be almost done. So first I'm going to translate along this vector here. So I'm going to go left 3 and then down 3 for each point. So left 3 and down 3 to get P prime, to get Q prime, and R prime. Okay, so here's my image after that translation. Okay, so P prime is at -2, -2. Q prime is at -1, 2. And R prime is at 1, -1. Okay, so next what I want to do is a reflection in the y equals x line. Okay, so that's that diagonal line with a slope of 1. So to reflect in that line, all you have to do is switch your x and y values. So to get P double prime here, I want to switch my x and y values in P prime. So I'll still end up with -2, -2. For Q double prime, switching x and y here, I would end up with 2, -1. And R double prime, I'd end up with -1, 1. Okay, and then all I have to do is plot each of those points. So P double prime is going to remain right here. Q double prime is at 2, -1. And R double prime is at -1, +1. Okay, so that would be my final answer. And yes, it's almost on top of the other one, but it is still reflected there. Okay, questions on these glide reflections. Okay, so again, you first do your translation and then your reflection. All right, so the composition of 2 or more isometries is still an isometry. Okay, again, an isometry is your transformation that keeps its size and shape as it is moving. Okay, so it keeps that size and shape. So we're going to do another composition of transformations, except this one's not a glide reflection. Okay, so example 2 here, we have the endpoints C and D to create this segment, are at our points right here, our coordinate points. We want to graph that segment and its image after a reflection first in the x-axis, and then a rotation about the 90 degrees about the origin. Okay, so it's listed that we need to do this reflection first. Okay, so that's what I need to do first to that pre-image, and then a rotation of 90 degrees. So that's what you have to do second. So first thing I want to do is graph my pre-image CD. So point C is at -7, +1. And D is at -3, +2. Okay, so here's my segment. Okay, so first thing I want to do for my transformation is a reflection in the x-axis. Okay, so point C to the x-axis is 1 unit away, so go 1 unit in the opposite direction to get C prime. Point D is 2 units away, so 2 units in that opposite direction there to get D prime. And then I can connect the two. And I do want to write out those prime coordinates. So C prime is at -7, -1. And D prime is at -3, -2. Okay, the second transformation that I have to do to this image I just found is a rotation 90 degrees about the origin, and it's talking about counterclockwise when it says this. So our rotation of 90 degrees about the origin, our rule is opposite of y, x, to change our coordinate. So this is why it was important to write down those prime coordinates so it's easier to change. So from C prime, this is how we want to change our coordinate point. To get C double prime, we need the opposite of our y value. Our y value is -1. The opposite of -1 is +1. So I would have +1, and then we need to keep our x value the same, and our x value is -7. So C double prime should be at 1, -7. Okay, next for D double prime, again, opposite of a y, our y value is -2, so you want to take the opposite of that to get +2, and then keep our x value the same, that's at -3. Okay, so after I find those double prime coordinates, I can plot my points. So we're at +1, -7 for C double prime, and 2, -3 for D double prime. Okay, questions on the graphing portion of your composition of transformations? We good? It's just adding a step in to what we'd already been doing. Okay, then on the back, so the composition of two reflections in parallel lines is the same as a translation. Okay, so if I have these parallel lines here, K and L, and I have my pre-image P, this triangle here, I reflect it over K to get my P prime image, and then I reflect that one over line L, which is parallel to line K, to get my P double prime image here. If I look from P to P double prime, it does just look like it slid to the right. Okay, so if you do two reflections in parallel lines, it's considered a translation. Okay? For the next one on the right there, the composition of two reflections in intersecting lines is the same as a rotation. Okay, so for both of these we have two reflections. Okay, with parallel lines it's a translation. With intersecting lines it looks like a rotation. So here, starting at my pre-image, if I reflect that over line K to get A prime, okay, and then reflect A prime over line L, I get A double prime here. And if I look at A to A double prime, it looks like it rotated to that image. Okay, and your center of rotation would be this point here, P, where those two lines intersect. So it's rotating around that center point. Okay, so if you have two reflections in intersecting lines, it's for one transformation, it would look like a rotation. Okay, so that's what we're going to do in our examples here below. So for letter A, we want to reflect the figure in line N and then line Q. Okay, so I want to reflect over line N and then reflect over line Q. This doesn't have to be perfect. Okay, so reflecting our smiley face here over line N. It would be upside down, right? Okay, so our face would be upside down. And then reflect that again over line Q. Okay, so you see those two reflections in parallel lines. It looks like it did just slide down. Okay, then we want to do the same thing in letter B. So first reflect it in line N. So first reflect it over this line right here. Okay, this one's a little bit trickier. Okay, so reflect it over line N. And then we want to reflect that one over line Q. Good enough. Okay, so it does look like it is rotating around this point here to that final image. Okay, so it doesn't have to be perfect as long as it's facing the correct way. Does that make sense? Any questions? All right, then the last part here. Many patterns in the real world are created using compositions of transformations. So this leaf pattern here is a glide reflection. Okay, so it does translate, okay, so or slide to the right, and then it would reflect itself over this line here to get to the new one. And that does that every time. So it slides and then reflects, slides and then reflects to get that leaf pattern. So I want you to look at A and B, and I want you to kind of come up with two different transformations you could use to create those patterns. So think about it. What two transformations could you combine to make those patterns? And then write them down next to those problems. Oof. Yeah. What? Did you do those two problems? All right, so I'm going to show you how I thought about it. Now, you could have thought about it differently than I did, and you could still be right. So after I go through it, if you want to ask me if that would make that pattern, you can. So for letter A, I took this center point here, and I split this into just this little piece here. Okay, so if I have this small little section, I could reflect that over to make this new one. So I could reflect over that center line there to make that new pattern here. Okay, and then take that entire thing and rotate it all the way around. Okay, so I reflected and then rotated. You could also take each one, rotate it until you get like halfway here, and then reflect that whole thing over. So you could do the opposite. You could rotate each piece and then reflect it over to get that pattern as well. For letter B, I took this piece right here. I had my center point here, and I rotated it to this new one. Okay, so I rotated that shaded piece to the new shaded piece here. And then I took this whole box and I translated it each time. Okay, so I rotated and then I translated for each one. But again, your patterns, you could use different transformations in order to get those.